Hi everyone, this video will serve as documentation as well as an insert for my new blog post, in both I'll be talking about this new asset pack that I'm putting together. It will create a flashing effect for an emissive on a material instance. And I'm going to go over how it works and how you can operate it. Let's get started. Okay, first I'm going to go over this material setup because I think it's important to understanding how it works. Basically, I took a bunch of stuff that I put together for a group project and now I'm turning it into an asset pack. And the first part of that is this material. So I made a material with a few example textures that I found, and I'll link to those textures to give some credit. It's got a base color, metallic, roughness, normal, an ambient inclusion, and most importantly, an emissive. So this emissive is going to go through a little system here. So the way it works is it goes through this switch, which will switch between a normal and a flash, which has an intensity here, and the way the switch value changes is based on what this custom node does. So it takes the time data in engine, it also takes a speed parameter and a duration parameter, and it plugs those into this equation. Float rate equals time times speed, flash duration equals duration, which is here, divided by 10 plus 1. So basically, I made this in order to get a modulus. It will possibly return a 1 if the f mod returns a 1, and if it doesn't, it's a 0. And depending on how the speed and the duration are set, it can go more quickly, or the flash can be on for longer. Then it goes through this switch node, which will actually tell the material whether it's flashing or not. And there's also an option here for making it change color when it flashes. So you can basically tell it whether to change color, and you can tell it what color you want to change it to, and it'll go through this custom node, which will return a UV times the flashing color times the intensity. And this change color switch will either return a 1 or a different color depending on whether this is on or off. So I'll demonstrate real quick. So let's say that this is a 1. It'll go through and take this system, and if this is a 1, it'll add the color change. Pretty neat. And over here we've got an instance of that material. So you can change whether there's ambient occlusion or a base color. Obviously the emissive is important for this to work, but you can also change the metallic or the normal or the roughness. So yeah, and now we come to one of the first actors in this asset pack. This will be the blueprint, both literally and figuratively. So we'll go to the construction real quick. So first off, it'll go through this, which will determine whether it'll allow a custom mesh or not. If not, it'll just take the regular square shape that's here and material. Let's say you try it out and turn it on. It'll take an object and whatever you put into this static mesh variable, it'll apply it to this object static mesh component, and then it'll go through here, and then it'll go to this node which says create dynamic material instance. Now you can put a material into this, or you can put a material instance into this, and they will both create a dynamic material instance. So you have material here, and I chose the dynamic the material instance rather than the material. And I'm putting the material in a folder that says do not touch, so people know to just deal with the instance and not the material itself. And then it will apply that dynamic material instance to the object. The dynamic material instance will be set to its own variable. As it goes across here, I basically made a Boolean checking whether the color step variable in this actor is set. So I have another color step variable here. So I have variables throughout this blueprint set up to adjust the parameters in the material instance, which is set from the material. At the end, it'll check yes, so it'll basically set this up correctly. And now over here in the event graph, we have a few actions and a few changes that can happen. So I set this up so that a bunch of custom events will react, because apparently if you turn this on in-game, it'll go through the event begin play event. But if you're doing this for a cutscene, it won't do that automatically, and you'll have to set it up in the sequencer. So I've set a bunch of events up so that you can call them in the sequencer. So when it's begin play, it'll have flashing Boolean checked in this branch. If it's true, it'll call the flashing event. If it's not true, it'll call the no flashing event. No flashing just sets the flashing parameter in the dynamic material instance to 0. If it is flashing, it'll set it to 1, which will turn it on, and then it'll go through this process of checking whether you have color change set, and you want to set that. If it's not set, you'll set the parameter to 0. If it's not, you'll set the material instance parameter to 1, and then it'll take the color step variable to change the color. And then at the very end here, basically I created two separate functions so that it does something differently. So it'll either call the glitchy event or the normal event, depending on whether you want random glitching. The normal call will just play this function, which will just take a basic speed, duration, and intensity value. Or if you want to call glitchy, it'll call this set timer by function node, and it'll call the randomizer function from that. And the randomizer function takes a minimum and a maximum of all of these values, and you can put them into new variables that create random floats. So it'll create some random glitching effects. And there's also a reset timer variable, so you can decide how often it'll change all of those randomizations, and pretty much all of the relevant variables will be available to you. They're all public. So you see these eyes right here. They're all public variables. So if we go out in the open here, this is an instance of the origin. You'll see there's a list of all the variables that you can access. And if random glitching is not active, it'll just take these and just have a regular glitchy pattern. If it is checked, then you can have like a minimum speed, a maximum speed in terms of the range of what you want the randomness to work with. And then there's color change if you want to change the color, etc. And reset timer. The last thing to note is this other blueprint called Copycat. And basically Copycat just casts from the origin to the copycat. All of the values for the material instance in the copycat will just reset from the origin. Get all actors of class. It's getting the origin class. And then it'll get the variables. And it's basically set up to act like the origin. So you can basically take this BP and copy it. It'll basically act the same way. And then we go to the event graph here, and it'll basically follow along another get all actors of class thing that gets the origin. You go through this, takes the dynamic material instance, and basically gets all of the scalar parameter values from the origin and sets the same values for the dynamic material instance in the copycat. Basically goes along all the way to the end until it's basically finished the same thing. And then I have a function set up here that's just flash match, which just matches all of the speed, duration, and intensity variables from the origin. So you have the origin actor here, you have a copycat here, put this here, put this here, and it all matches up. And we can stop this for a second and try out. You just got to remember which one's the origin and which one are the copycats. And then we can turn on random glitching. It makes it look like they're broken. Yep. Looks pretty good. I might try to do a little more changes before I submit this, but yeah, I think I'm going to submit it pretty soon.